Hello, and welcome back to my channel. And today we're going to do some math problems. So let's get into it. We'll be doing 2.7, 16, 18, and 20. And then so there are directions for this. Always read your directions, right? It says each of the expressions can be rewritten in radical notation like this, the nth root of a to the m, or with rational exponents like this, a to the m over n. Rewrite each expression, each of the given expressions in the form that's missing. So number 16 is in the form of rational exponents. So they want me to rewrite it using radicals. Okay. So how do we do this? So the first thing that I do is I rewrite it, right? So I know that I could either write it in radicals now or do properties and then rewrite it. So I'll do both just so you can see both and see which way you like better. The first way I'm going to do it is I'm going to use the exponent operations. So here we have 9 to the 2/3 times 9 to the 4/3. And so whenever you have the same base, it means that you can add your exponents. So I'm going to add my exponents as soon as this shows up. There it goes. So I have the same base, so I keep that, and then I add 2/3 plus 4/3 is 9 to the 6/3, which is just 9 squared. Okay. So they don't want you to necessarily simplify what 9 squared is. They just want you to leave it alone. The other way to do this, which again, it should come out the same exact way, is using the radicals. So whenever I write a radical, so 9 to the 2/3 times 9 to the 4/3, right? So this denominator here becomes the index for your root. So that 3 sits there. And then I just write 9 squared times, again, writing that cube root of, because it's the same denominator, and then 9 to the 4th. Well, according to this, as long as I have the same radical, then I can multiply the two numbers underneath. And when I multiply them, I keep, oops, that looks like 94, sorry. I keep the cube root, I keep the base as 9, and then I add 2 plus 4, which is just 6. So the cube root of 9 to the 6th. Okay. And I think that's all they wanted you to do in terms of rewriting it using an exponent. I mean, if they gave it to you in exponents, then they wanted you to rewrite it using radicals. And if they gave it to you in radicals, then they want you to rewrite it using exponents. So if you think about it, this does simplify to this, but they just want you to leave it alone in terms of radicals here. Okay. I'm just going to move it up so it's out of my way. Excuse me. Yeah. So then the next problem that I'm going to do is this one. And this one is in radicals. So now they want you to rewrite it using exponents. Okay. So the very first thing I do is I just write 27 and then a to the 5th and b squared. Right. And then I'm going to deal with the cube root. Now the cube root, remember we talked about it up here, the cube root is rewritten as a fraction with a 3 on the bottom. So I'm going to take each of these guys up to the 1/3, to the 1/3, and to the 1/3. Okay, so that's where the cube root is now. So then they'd want you to simplify, I think just right here. So my final answer is going to be 27 to the 1/3 times a to the 5/3. Now remember, when you have a power to a power, meaning two exponents, right? Then you're going to multiply them. So that's 5/3 times b to the 2/3. Okay. And the last problem we're going to do is this one. Now it's in rational exponent form, so we're going to write it in radical form. So the very first thing that I do is I make a square root. I have to make a square root because of the denominators of 2 and 2. Here, I'm going to write it as a cube root and leave a small guy right there. Okay, so I'm going to collect my denominators of 2. So that would be 9 cubed times t. 9 cubed times t. See the square roots with the 2's on the bottom? And then for this one, I'm just going to put s to the 6th, which this to me looks like you can simplify this, but they didn't simplify this. So I would just kind of leave it because they're asking for you to rewrite it in its other form. All right, hope that makes sense. Have a great day. Bye.